live stream. Learn how to ditch those boring orange and gray score boxes and up your scratch game with fancy graphical scoreboards. Plus, our staff artist, Kal, shows you how she used simple shapes to create this beautiful nature scene. And game reviewer Huynh tries to break out of a scratch escape room. All this and more coming right up on the Chromeworks live stream. Good morning, Internet. Ooh, a little earthquake there. How are we all today? Nice to be back again for another live stream. We've got some interesting stuff coming up for you. Firstly, an update on our AMV project. It is still in a holding pattern. Freakadroid, our epic post-apocalyptic AMV animated music video project, is coming along quite nicely, but we are waiting on Music Man Joe, who is composing our soundtrack for us. We have a soundtrack done up, but that we're borrowing from a famous 1980s dance song, but we're going to do a cover of it. And Music Man Joe, if you're out there, please help. We need your help with this to continue with this project. And so after that, things are going to start to happen very, very quickly. So you can look forward to some updates on that coming up soon. So our next big game release project, which I'm going to be releasing probably next week or the week after, is a Tetris game. One of my co-op students, Wang, who's been doing a fantastic job coding for me, has come up with a very authentic version of the 1980s popular arcade game Tetris, which I was personally super addicted to as a kid. I'm going to give you a little sneak preview right now, just because I'm pretty excited by it. So let's get over there. So this is Wang's Tetris game. As I said, it's not quite ready for release. We have a little bit more polishing to do, but I can show you the beta test of it. It's looking really fantastic. And yeah, let me turn that audio down a little bit. As you can see, it pretty much captures the essential essence of the original Tetris game. Quite lovely. You can spin the blocks around, drop them, and they fall into place perfectly. Let me just get one line done here. I don't think I'm going to do it. All right, I don't want to waste too much of your time with this. So it's looking really good, and I'm super happy about it. One of the things that you might notice about it is the graphical scoreboard that we've set up here. Good morning to Adam, who's joined us on YouTube. Good morning also to Top Secret Asian, Andy, who's my moderator on the YouTube chat, as always. If anyone else is out there lurking on the YouTube chat, please do drop us a hello and tell us that you're there. I heard from Liam Shaw from Maine a little bit earlier. I'm not sure if you're still there with us, Liam, but good morning if you're still there. All right, anyway, so one of the things that I was going to talk about today that I got really interested in is Wang came up with a really clever way to get graphics going here. Let me get this game running again. You can see that instead of using the ordinary Scratch graphics to display numbers like this, like the statistics here and the level and the number of lines covered and the score, these things are all being covered off with custom graphics, right? And this is a real way that anyone who's serious into game design is going to want to customize their games. You don't want to go with the stuff that Scratch provides you, because we've all seen the same boring variable boxes everywhere that we've gone, right? So we've got stuff like a score box like this one here. This just looks so generic, right? So the real pro MLG way to go about this is to get your own custom scoring block going here by designing your own letters. These are hard to see, of course, because they're in the wrong color, but you can see here by designing your own letters to match whatever kind of format you want, and then get those into the game. Now there's some interesting coding techniques that are involved in getting there, so I decided, inspired by Wang's work here, that I was going to teach a little lesson today on how to do that, on how to get custom graphics into your scorecards here. So without further ado, I'm going to release this video called Score with Graphics. And I'm going to release it as a standalone project, as a clip at 11 o'clock today, but I'm going to give you the world premiere of my little video right now, my latest tutorial video, and here it comes right now. Scratch's orange and gray variable boxes work okay, but they get a little monotonous after a while. Today I'm going to show you how we can create custom graphics and code them to make our own really cool scoreboard screens, like this one, or this one, or maybe even something like this. It's really not too hard at all. Let me show you how. So I'm going to be showing you two different methods here for converting a plain old variable in Scratch into something a little more graphical that will allow you to tweak colors and play around with design and do something a little bit prettier. In order to do that, we're going to have to start with a set of graphical numbers, and you can see that I've got something set up here where I have some pixelated looking little numbers showing up. The first costume is 1, and then we go down the list here until we get to 9, which is the 9th costume, and then the 10th costume is the digit 0. We're going to start by placing these guys down on the screen here. You can see that I've just got a simple loop here where we have a starting position and we just shift these characters to the right by 22 pixels each time. Along the way though, we're going to stamp these guys with a number. I've set up a local variable here. Local variable meaning when I went to make a variable, I clicked on this little button here that says for this sprite only before I name the variable. Now that's very important because when you're working with clones and you use a local variable, each of the clones will be given a different number, and that's how this code will know which digit to change with which number. So let's go ahead and do that. I'm going to stamp the first of these digit clones with the number 1 and the second with the number 2. And just to demonstrate that, I'm going to have each one say its digit value when it's created on the screen here. So let's go ahead and do that. And you can see that our first digit is 1, and then 2, and then 3. And we're going to be able to use that number to tell these clones which ones need to change at any given time when our value of our score down here below changes. Okay, so let's get rid of this say here. Now we're going to want to begin a loop here where we're going to be switching costume forever to match the value of our score. If I do something simple here like switch costume to score and I run my program, you can see it's going to be constantly going around here updating it to match whatever the score is. So if I set my score to 1 here, for example, you can see that my readout now goes to 111. And that's what I would expect to happen here because every single one of these guys is looking at the score and changing it to costume 1, which will give us a number 1. Now, we want each of these guys to operate differently though, right? We want, in the case of a bigger score like 100, we want that first clone to show the number 1 and the next 2 to show the number 00. So we're going to do that by using a block here that says letter 1 of Apple. This basically looks at any string of text, in this case Apple, and returns the first character or the second character, which would be a P in this case, of any information that's put in here, including a variable. So if we go in here and go grab score and put it where the word Apple is, now we can actually identify individual digits inside the score. So my score, let's set it to 100 here. And if I look at letter 1 of score, it comes out as 1, and letter 2 comes out as 0, and letter 3 comes out as 0 as well. Perfect. So if I take this green square modified with the score variable here, and I substitute this number here with the variable digit, now something interesting is happening here because every single one of these guys has a different value for the digit variable. So every one of these guys who reads this block now, if I plop this into here, is going to read this differently. The first guy who is stamped with the number 1, is going to be looking at letter 1 of the score. The second guy is going to be looking at letter 2 of the score, and the third guy is going to be looking at letter 3 of the score. Now watch what happens when I change my score by 20 here. I'm at a score of 120, 140. Let's change it by 25 instead. And you can see that my numbers are keeping up nicely with the score variable now. So I've pretty much licked the problem. The only issue though is if I try to enter a smaller score, let's set the score back to 0 here again. And now if I try and change the score by 1 at a time, for example, here you can see it's going up by hundreds. Why is that? Well, the number I'm entering here only has 1 digit in it. So the software is looking at the first letter of the word here, and the first letter is indeed 1, so it's putting it into this spot here. There is no second letter or third letter, and that's why these ones aren't changing. So in order to get a system like this working, before we process this, we're going to have to change whatever the score is into a 3-digit number, and that will clean up this little issue here. So that's fairly easily done. It's going to involve some if statements though. So I've set up a couple of if statements here. I've pre-baked these. So what's happening here is if my score only has 1 digit in it, the length of the variable score, if it's 1, then we're just going to add a 00 onto the score, and we're going to write that to a new variable called display score. So the display score, instead of being 1, is going to end up being 001 when we add 1 to the score, and that's going to keep these digits in line with each other. If the length is 2, then we're going to add a single 0 in front, so it'll be 010 for 10, for example. And if it's a score of 3 digits or more, then we're just going to make the score equal the display score here. So now we just have to modify this block a little bit here. Instead of switching to the score, we need to just switch to the display score. And now we have a uniform 3-digit number coming in here, and each of these will be updating based on the placement of the number inside that 3-digit code here. And that should solve all our problems here. So let's go ahead and run a test here. We'll set the score to 0, and our numbers go to 0, and then we'll start changing it. Now to save time testing this, I've programmed these cats to add to the score variable here. So if I click on the orange cat here, you can see my score goes up by 1. My green cat here adds 10 to the score, so we get 14, 24, and the reddish one here changes it by 100. And you can see that no matter what I do to this score, as long as I stay below 1000, my score always perfectly matches the score variable here. So that's method 1. It works quite nicely. I wanted to show you guys a more advanced method that uses a little bit more elegant code here that's just a little bit more difficult to understand, but I think it's worth the effort if you guys want to take a deeper dive into this process. So let's jump over to our method 2 sprite here, which I've colored the numbers green in just to differentiate them. So you can see that we coded things a little bit differently here. For starters, every time we create a clone, we're actually moving to the left instead of moving to the right, which means that our first digit is going to be the ones digit, and then moving to the left, our tens digit is going to be the next one, then our hundreds. The benefit of doing it that way is that our number is going to be expandable. Right now I'm making 3 numbers across a row here, but if I change this loop to a 5 or a 6, we end up creating massive numbers that will help us out if we're in a high scoring game. So this system here is a little easier to set up if you're working with bigger numbers. Now the other thing you've noticed here is that this local variable that we're changing here, I've changed the name of this to D instead of digit, but it's really basically standing in the same place. This is an identifying number that's going to let these clones tell each other apart. But the number that we're stamping them with is actually matched up with the digit place of this number. So the first time around this loop, we're going to create the clone, and the D is going to be set at 1 initially. But then as we come around this loop again, we're going to multiply that number by 10, which will make the second digit here, the middle one, have its ID number be 10. And the third one is going to have an ID number of 100. And then if we were to go with more numbers, it would be 1,000 or 10,000. So you can see that right here. If we hit the green flag here and they say their ID number, we've got our 6 guys still being made here, and the ID number of this 6 guy is 100,000. Let's change that back to 3, and you'll see that this guy's digit is 100. So he already knows his digit placement based on this ID number. Let's get rid of this say block here. And now once again, we're going to be changing our costume forever in order to keep track of where that score is going. So we're going to need our score variable again. We don't need the display score in this case, because our new system is going to actually account for the fact that we have a different number of digits depending on what our score is. And that's one of the things that's going to make it a little easier to expand this. So we want to switch costume, in this case, to a mathematical formula. We're going to take our score and divide it by this digit value. And then we're going to take the output of that, whatever that number is, and we're going to find the floor of it. Now, floor is a term from calculus that you guys won't have seen in math in high school until a fairly advanced age, and you certainly won't see it in elementary school. It just means round the number down to the nearest whole number. So if I have a number like 2.4785, the floor of that number would be 2. I can show you that right now. So the floor of any number like this is going to end up being the next whole number. The opposite of that is the ceiling, and that's just rounding it up. So the ceiling of this big complicated number would be 3. So it's basically just rounding it up or down to its nearest whole number. So we're going to take this formula here, the score divided by that D variable, and then round it down. Now, why we're doing that doesn't seem immediately obvious. So what I'd like to do is show you guys a table of values like we do in math class, and see how under different scores, how this formula relates back to the costume that this guy is supposed to be wearing. So this table here shows what the score divided by this D variable would be under different circumstances here. So let's say we have a score of 5 going in our game right now. So this hundreds digit here, the one that's marked with the number 100, it's going to divide itself by 100. So the score of 5 divided by 100 comes up with a value of 0.05. Now the floor of that is going to be 0, right? Because that's the nearest whole number. So that first digit in our score is going to be 0. The second digit here, the one that's marked with a 10, we're going to divide that number, 5 divided by 10, and it comes up with 0.5. And again, the floor of that is 0. The third one we're going to divide by 1. So 5 divided by 1 is 5, which the floor of that is still 5. So our final output here is 0, 0, 5. And so the first costume will switch to a 0, the second will switch to a 0, and the third one will switch to a 5. Perfect. Okay, so now let's try a bigger number. Let's try a 2-digit number in there. So if we take a number like 32 with our score, if we divide that by 100, we'll get 0.32, which still adds up to 0. Divided by 10, it becomes 3.2, which gives us 3. And the third digit here, 32, divided by 1 is 32. Now this is where things are a little bit more confusing. So it can't switch to costume 32. What's going to happen then? Well, there are 10 available costumes, so it's going to switch through 10 costumes, then do it again, and be left with 2 of them. Then it's going to go to the first, second costume. So basically when you have costumes that are more than the number that's there, especially if you've got 10 costumes here, we can basically ignore this whole first digit, and the output is going to end up being just the second digit. it. I hope that makes sense to you. So it's actually cycling through 32 costumes, but because there's only 10 available, it's burning through the first 10, then the second 10, then the third 10, and then on the fourth time around, it stops at the digit 2, and that's the costume it's going to be wearing. So our final output is going to be 0, 3, 2, which gives us the number 32, which is exactly what we were looking for here. Let's try that one more time with a number with 100 digits. Let's say we're doing the number 157. You can see the same kind of thing happens here. So divided by 100, we end up with a number that's basically 1 when we take the floor of it. This number here divided by 10, it's 15.7, and the floor of that is 15. So just like with this number, it's going to go around once, and then the second time around stop at 5. So the output's going to be 5. And for the third number, we've got 157. And again, it's going to ignore those first 2 digits and put out a 7. So our final output is going to be 157. So no matter what our score is here, whatever the input score is going to basically match the output score with the handy zeros put in here. So we no longer need an if statement to keep track of our zeros. And we're also able to expand this out to as many digits as we want it to. Let's go have a look at that right now inside our program. So now that this is all plugged in, you're seeing our score is 0. And now when we add 1 to it, you can see both these numbers are keeping track perfectly of what our score is. Let's try adding 10 to it. Our score is 15 now, 25. Let's add 100 to that, 125, 225. And no matter what we do to these numbers, they basically keep tracking with what the score is going to be. So now here we have a perfectly aligned little numbering system that we can use in our games that will let us control the look and feel of everything we're doing. Perfect. And as I said, you can expand this out to any number of digits you want to. We just have to go around this loop a couple more times. Let's say we went 6 here. Then we would end up with a giant number based on 100,000 here. And you can see, let's add some more digits to this. So 421, 5, 6, 7, 8, 9. And when it rolls around to the next number, you can see it automatically takes that into account. So this number is basically expandable out as far as you need it to be, just by making that loop go around to the maximum number of digits that we're going to want to add there. So there you have it. That is 2 different ways to do a complex numbering system in Scratch that will let you really put a nice graphical touch on your projects. I hope you enjoyed this. Please go ahead and make a scoring system for me and send it to me. If I see a really cool implementation of what you learned here today, I'll show it on my future live streams. Thanks a lot. Well, thank you for that very insightful and interesting report, Mr. Tomac. I thought you did a fantastic job on that. So, yeah, I was so impressed by this code when Wang first showed it to me, because we've got multiple different sprites here. In this case, well, if we're doing a 5-digit number, we've got 5 different sprites all being controlled by the same one block of code, and each one of them is behaving differently because we've stamped each one with a different D variable. The elegance and simplicity of this code and the fact that it just works for any numbering system is just so impressive anyway. So I have sent you guys a link to this project. If you want to steal this code, please use it in your own projects. As I said, all you need is a custom set of graphics like this one, where you've got numbers from 1 through to 9 and then over to 0. So 10 different graphics all organized in order, and then just this little bit of code here, these couple of blocks, will get you going with a really cool graphical system like the one in this sample project here. You can see I've modified it a little bit from the version that you saw on the air here just a minute ago. So I'd encourage everyone to give that a try. Hi to Cursor V2 from who knows what parts. Tell us a little bit about yourself, Cursor, if you'd like to have a little shout out on the stream. We're always interested in where our viewers are coming from. So where are you watching from? And maybe tell us how old you are, if that's not too personal a question. So let's move on here. I think we should get out of math for a little bit because you guys, if you've been watching closely, your brain's probably hurt by now. So let's turn our attention to art in Scratch. Some of you guys have met Kal, who was our artist in residence, and she has been doing a fantastic job doing fun little drawing tutorials every week. This week, we put her on the task of how to take simple shapes in Scratch and modify them to make new shapes. Now, you guys have already seen this process probably before, but if I grab the select tool and click on any control point here in Scratch, I can delete it and turn one shape into a totally different shape, or I can just manipulate the individual shapes, of course. You can also add extra control points. And you guys will probably also remember that we can change these we can set this up as a curve system here, or we can click on this to make it a point and then get something a little more angular going here. So depending on how you want to make this go, you can take these simple shapes. We call them primitives usually in graphics. So take these primitive shapes and turn them into something totally new. If, for example, I wanted to do like a Pac-Man shape with this guy, I could just click some new control points here, click to make them pointed. Oh no, I probably just don't want to make that pointed. I want to make this middle one pointed. And then tuck it in. And suddenly I've got a lovely little Pac-Man kind of shape going here. So anyway, Kal is a far better artist and explains it far better than me. So I'm going to show you her tutorial for the week on how to take simple shapes like this and make something truly amazing with it. So here she is right now.
Hey guys, today I'm going to show you how you turn these two simple shapes into this drawing. So let's go. Using something I learned that if you delete a control point, you actually can half a shape, or you can even turn it into a triangle, which I found very helpful, and I'm going to show you how I use that technique into making my drawings. Using simple shapes, I started on the background by just making a yellow rectangle, and then I used the shading techniques I taught you guys in last week's video to make a sunset, which at first was a little difficult, but once you got the hang of it, of just using radial tool and transparency, it's pretty easy to do. I kind of messed up with the sun trying to figure out how I liked it, and then I just used my favorite technique, which is just radial light shading, which is just the radial tool and transparency. So now moving on to the landscape part of the drawing, I chose a color that wasn't fully black, it's like a dark gray, and then I started halving my circles to give me little hills. I know I could have put full circles, but I like the control I got with doing the half circles. Moving on, we're making a savanna tree, which is supposed to look like this. Mine kind of looks like one like those, but making branches, I just made a triangle out of a square, and then now I'm making the little tree top part, and I'm making sure it's fluffy sort of looking by using the half circles. Making a triangle out of a square with a deleted control point, I'm gonna make my hill, and then we're just gonna make little ferns or dead grass, you can call them whatever, and then we're just gonna put a few on the hill to make it look like it has texture. I added a pond using the radial tool as shading because I think that it needed something more than just black. So I just halved it so I get the shape I like. And then I added the sun reflection in the water, and then I just used my light radial tool to give a little glow. And then I think that the water needed something to break it up from the border so it didn't look so cut off. So I just copy and pasted a bunch of the little ferns or dead grass that we had on the hill just until I was satisfied with how it looked. Which leaves me with my final image, which is this. I hope you guys liked it, and I'll see you guys next time. Bye-bye!
Thanks for that, Kal. Yeah, I'm really enjoying these little art tutorials. I think there's a lot of untapped potential for art in Scratch. So you guys know that I'm always talking to Scratchers out in the real world, on the Scratch website as well, who are posting and asking me to have a look at their work, and I'm always happy to look at people's work. This week I've been communicating with an ordinary Scratcher by the name of Kittens26. and I can show you some of her work. I don't know much about Kitten, other than she has 400 followers, and she's a big fan of Zevo, who we interviewed a couple of months back, the famous celebrity scratcher. She does a lot of animation type stuff, and the one project that really caught my interest was this one called Zevo Fan Art. It really shows off Kitten's lovely artistic skills here. So these are some hand-drawn representations of some of the work that that Zevo's done that she's tried to duplicate. I believe you are a she, and I'm sorry if I misgendered you, Kitten. Anyway, a lovely little project here. But what really impressed me with the way that you had this little slideshow going, I had a look inside Kitten's art here, and I've kind of created my own variation on this slideshow project, and I wanted to share it with you guys out in TV land, because I think this is a really useful technique for showing off your own art projects. I'm pasting a link right down into the chat right now that you can use to follow this along. And so all this is a simple project that emulates a classic slideshow projector. Let me show you what it looks like here. So I'm going to get my system audio going here. Here we go. So if I tap on the screen or hit the right arrow key, you can see that we get a little kind of light dimming flashing effect here. And then we switch to the next one. We can go backwards by hitting the left button, and to the forward by hitting the right button. And you can also click the screen to advance the slide. Ooh, I thought that I'd done that. I guess I haven't enabled that part yet. Anyway, so a nice little project. I wanted to show you some of the different techniques that I use that are a little bit different from what Kitten did. I took her approach and kind of put it on steroids a little bit here. So the basic approach is just using glide commands. Now, so this is a custom block here called next slide that performs all the functions here. There's a bunch of glide commands. I've taken these 0.1 second delays here, and I have changed them into 1 second delays just so I can show you in a little bit more detail what's happening. So the first command here just takes the image that's all centered on your screen here, shifts it over to the left just like that, and takes it as far off the edge of the screen as you can go. Now different sprites can go a different amount of depth off the edge of the screen. So usually when I'm trying to figure out just how far I can make something go, I just keep telling it to change its x by -1. And so if you've got something on the screen here at a different location, like this one here, I can start sliding it over until the numbers stop advancing. And that's one way to figure out how far Scratch will let you move an object. So you can see its x coordinates down here, -378, and they keep going farther and farther. And then at some point when I click, they stop moving, right? Let's try moving by 1 and see if we can get it a little further over here. Yeah, and so -467 is as far off to the left as we can possibly place this. I thought I had 482 here, which came up in my earlier thing. Anyway, but you'll come up with a number that will work for the farthest extent of it. So once that's done, we hide the object, and then we secretly change its costume while it's hidden, and then we re-show it again. And from there, we just pop it over to the left side of the screen. So just clicking on this once will bring it over to the left side of the screen wearing its next costume. And then we glide it just about to the middle, but actually a little bit too far. And then just to give it that kind of slideshow effect, we move it back again. So we move all the way to the left, and then we move a little bit too far, and then we reverse course and move it back again. While that's happening, I've got this little sprite here called Vignette, and let me show that to you. So that is just a black screen that has transparency in the middle of it, and I've used that to cover up my object here, but I've made it kind of transparent. So if you look at my code here, this ghost effect is set to 70% here. So let me get this running for you again. I don't think this is at the front anymore. Let's actually change that in the code to bring it to the front. Where's my go to front? It's under looks. Oh, there it is, go to front layer. There we go. And we'll have to recenter this object. I think I've messed it up when I was trying to demo some things for you a second ago here. There we go. So you can see that with a ghost of 70%, it kind of covers up our image and gives it this look like it's being backlit a little bit, like you would in a typical slideshow. And then I've got this little bit of code here that will just make it fade out and fade in a little bit. Just a titch here, and that coincides with this sound effect. And I downloaded this sound from freesound.org, my favorite website for grabbing sounds off the internet. A really useful website, and I just grabbed this sound, which works quite nicely. So between all of that, I think I've got quite a nice little slideshow format going here that works quite nicely. So you can see my touching the screen still isn't working, and that's just a simple matter of fixing in the code because everything else is being connected when to one of these custom blocks, next or previous slide. So if I just go when the sprite clicked, go to next slide. Oh, and the reason that's not working, of course, is because the vignette is covering it up. That's why when the sprite clicked isn't working right now. So the only way to fix that is to create a broadcast, I would imagine. So let's go back to this vignette. I'm going to fix this on the fly here. I'm going to show you some troubleshooting here. So I'm going to say when this sprite clicked. So we have to click the vignette. Then I'm going to broadcast a message, and the message is going to be next slide. So I'm not able to click on the original slide because it's being covered up by this semi-transparent sprite, right? And so this is how I'm going to solve that problem. When I receive that next slide message, then I'm going to run my custom block. I can't run the custom block inside the vignette slide because it doesn't contain the costumes, right? And this custom block will only work on this particular sprite. Okay, I think our problem should be solved now. Now when I click, yeah. So clicking on the screen now advances my slides. Beautiful. Okay, so yeah, so that's a nice little slideshow project. I believe I've shared the link with you guys. It is in the description, but let me paste it into the chat one more time. So Cursor V2 told me he lives in the United States. It's a very big country, though, and I was telling him that that if he tells me what state he comes from, I promise I won't go to his house and try to explode it or anything. So really, guys, I'm not asking for your home address. I just kind of want to know what part of the world you come from. And if you, there's a big difference between living in Maine, like Liam, or living in California or Oregon, like our friend Cannon does. So so just letting me know what state you come from. But if you're shy, no big deal. All right, guys, let's move on. I have one more piece of prefab content for you, and that is my game reviewer Young has had a look at digital escape rooms, and I want to give you a little report on how escape rooms work. And he's found a classic example of the genre, which, oh, Cursor says he's shy. Okay, well, we don't need to know what state you come from. Somewhere in the United States, Cursor, somewhere in this country of 350 million people is Cursor's house, but we'll never know where it is, so we won't worry about it. All right, so without further ado, here is Young's review of Scratch escape rooms.
Today, we're going to be playing an escape room, a fun Scratch game format that challenges players to experiment, explore, and solve logic puzzles to progress to the next level. Escape rooms are a kind of puzzle game where players are locked behind a closed door and must race against the clock to find a way out by searching for clues and solving puzzles. The genre started off in the video game world, but in the 2010s, real world escape rooms started springing up everywhere, and were becoming quite popular before the pandemic put a stop to the real world fun. In the past few years, however, creators on Scratch have picked up where real-world escape rooms have left off, creating a fun new genre of puzzle game where players click to find clues they need to solve complex logic puzzles. This week's featured game is Escape the Room. This is a really good example of the escape room game format. And in this game, you play as a teenager who is stuck inside a haunted house who has to solve a bunch of devilishly hard puzzles to make his escape. The creator of this game is Billy Greco. They have been a scratcher for 7 years and 8 months. However, they haven't been active recently, which is the reason why the escape room game isn't fully complete. It only has 5 levels instead of 9 as it is advertised. This is one of their only games. They've made games in the past, but they haven't been that successful or, developed. But the escape room game is one of their first. They have 132 followers, which is pretty low considering that the Escape the Room game has like over 100,000 plays, so that's just a bit surprising. Most escape rooms, Escape the Room is all about observation and experimentation. I'll try not to give away too many spoilers here, but let's have a look at the first level, since it's a pretty simple level. So first off, you want to just find whatever you can do. So first we find off the keypad right here, and we clicked around the box. There is a duster within the box. Now let's look for some things that need to be undusted. So this looks like the only thing that can be undusted here. That shows 4 letters. That is either 4 9s or 4 6s. We can try both of them. It does look like there are 4 6s. So sometimes there's just a bunch of random stuff, like that table and like that clock, that have nothing to do with the level. So don't be thrown off by that. Just keep continuing on with the level that they provide you with. Thank you guys for watching. Don't forget to like and subscribe.
So thank you for that, Young. Yeah, I've called up the escape room here. I've left a link to it in the chat, and it's also down in the file description, of course, if you guys are interested in checking out this game. A really professional-looking example of the escape room genre. You'll find lots of other escape rooms in Scratch, though. It's becoming a very popular format, and it's a really nice little coding exercise, too, so I would recommend any of you guys who are new to coding, who are looking to do something interesting, that this is a great place to start in your own projects. So one last project I wanted to show off to you guys today was someone uploaded a project in my Scratch student showcase the other day. I've never met this fellow. His name is Chow Noi. He says he's from the Pacific island of Nauru, and I'm not sure whether that's true or not. I'm finding a lot of Scratchers are just putting fake countries in their profiles lately, so I can't be sure whether he actually comes from there or not. That would be very interesting if he did, though. Anyway, he has crafted the 3D platformer game. Now, I'm always a little bit dubious of 3D games in Scratch. Scratch is not a format that's well suited to 3D, and because it's a fairly slow kind of operating system, this stuff doesn't render very well. But I'm always impressed when I see examples of these projects on Scratch, and so since he put this in the showcase, I thought I would have a look at it. So this is called 3D Platformer Engine by Chow Noi, and you can see that he's done a fairly good job here of rendering the 3D environment. You can move around with the WASD back and forth, and a couple of the different sprites. Let me turn that audio down a little bit here. The different colored sprites here all do something different. So for example, if I step on the yellow blocks here, they will start bouncing me like that. The blue blocks are good, and the green ones are your goal. So you're trying to get to the green block to get out. If you step on a red block, you get put back to the beginning again, and that's basically lava, right? So the goal is to jump around and get to the green platform and there we go. And when we hit that, we automatically get loaded into a new level. So a really interesting example. This is one of these projects that's done entirely using the pen tool. There's no graphics in here. If we actually go looking at the at the project file itself, there's almost no graphics inside here. And so it's all being done completely inside the pen tool with a whole lot of custom blocks. So I'm fascinated by 3D in Scratch. As I said, it's not the best platform for doing it, but anytime anyone manages to pull it off this expertly, I really have to give them thumbs up. So this is a really great project. All right, so we are running out of content for this week's episode, and that's fine because the time's almost up right now anyway. Next week, we're going to be back, and Music Man Joe, if you're out there, I would dearly love to continue working on our AMV project, but I need your help, right? So if you are out there, Music Man Joe, we are waiting on your music file so that we can continue working on Freakadroid, our AMV project. So hopefully, fingers crossed, Music Man Joe, please, if you come up with this project in the next week, then we are going to get working and we will have some really interesting progress to show you next week. In the meantime, keep scratching, everybody. It was lovely having you out here. And please come on back next week. We live stream every Saturday at 10 a.m. like clockwork. And I usually have another Scratch tutorial project of some kind that I release later on Saturday as well. So there's always some new content for you to play with on Saturday. Thanks a lot for stopping by, and I will see you again soon, guys. Bye now.